Good morning, welcome back. Let us continue our discussion regarding the fourth model, that is tree. Okay, we see what do you mean by tree, what are the different types of trees are there, and what are the operations we are performed on the tree, and what do you mean by binary search tree, and these are the things we discussed in the previous class. Okay, today we are going to see some specific other operations you can perform on the trees, okay, which as mentioned in your syllabus. Okay, see what are the other operations you can perform on the trees in sense. Okay, I want to find the maximum value which are found at the binary search tree. Okay, a node which having the highest magnitude, and the next one is minimum value. Okay, minimum value which are found, okay, in the binary search tree. Next one is number of nodes, how many number of nodes are there in the binary search tree, and next one is the count the number of leaves. Okay, leaf node. Okay, leaf node in the sense the node which does not having any children, that are called as leaf node. Okay, how to count those leaf node we are going to discuss in these videos. Okay, now first, what do you mean by binary search tree? As already we discussed in the previous video. Okay, a binary search tree is a tree where a node which are towards the left node, okay, left subtree will having the value less than the less than the node, and the trees, okay, leaf node which having at the right side having the magnitude higher. Okay, see, assume 50, 70, 40, 80, 65, 30, 20, these are the values. I want to search, I want to build binary search tree for these inputs. Okay, how to build the binary search tree for this instance? Okay, the first value becomes the root, okay, the value next comes, okay, which are the values which are comes towards the next. Okay, if it is greater than the root node, it is goes towards the right. If it is less than, it is supposed to go towards the left. Okay, see 70 in the sense it is greater than 50, it is supposed to go towards right side. Okay, next 40, okay, it starts comparing from the root node. 40, okay, it is less than the 50, for that reasons it comes towards the left side of the root node. Okay, next one having 80, okay, 80, see compares from the root node, greater than 50, yes, goes towards right, greater than 70, yes, goes towards right of it, 80. Next we are having 65, greater than 50, go towards right, less than 70, go towards left. Okay, next comes under, okay, 30, less than, okay, see next one we are having 30, less than 50, yes, less than 40, okay, go towards left of it, 30. Okay, assume we are having one more value, that is 35, okay, less than 50, yes, okay, greater than 45 is greater than 40, yes. Okay, this may be my tree. Okay, this is my tree, assume, for the given these inputs. Okay, how I going to calculate the 45 instance? 50, okay, 45 is less than 40, goes towards left. Okay, 45 is greater than 40, for that reasons it goes towards the right of it. Okay, this is my binary search tree. Okay, now the other operations let's going to perform. How to perform, okay, this maximum value. Okay, how to find the maximum value in the binary search tree, and how to find the minimum value in the binary search tree. That is the concept we are supposed to discuss now. Okay, how to find maximum? See, by seeing itself. Okay, visually if you see that one instance, okay, rightmost corner of the tree, at rightmost, okay, leaf node will be the maximum value, leftmost value will be the minimum value. If you, okay, directly view that one, you can see that, okay, you can observe, okay, this is the strength of the binary search tree. Okay, that is maybe the property 2. Okay, how it going to perform, and see that one simple. If any tree if you given, okay, traverse towards only to the right, okay, okay, the last value which is not having any children, that may be the maximum value. Okay, how to get the minimum value? Traverse towards the left, okay, that finally the leaf node which does not having any children's, or does not having any child node, that will be the minimum value. Okay, that is the, okay, that is a key concept is supposed to keep in mind. Okay, traverse towards only to right, get the maximum node, traverse towards only to the left to get the minimum value. How it works, let's see. Okay, see, I having the function here. Okay, I having a function here. See, you can look after this. See, I want to find the maximum value. Okay, I just explain the program and start tracing in that example. Okay, see, what are the concepts are there? Return type is max. Okay, so return type is node. I going to return a node value to the main function. Okay, next the maximum function is called, it going to brings root information. It going to brings the root information from the main function. Okay, next I going to call a current, a temporary variable, that is current is the temporary variable. Okay, see, now if root is null, when the root is null, okay, if no element present or no node present in the tree, and the time root is null, and the time return root itself. Okay, root itself. Otherwise, okay, current is equal to root, while current of right link is equal to null. Up to current of right link is equal to null, it keeps on tracing. Okay, say traverse the things. Okay, current is equal to current of right link, it keeps on traversing towards the okay, rightwards. Okay, it traverses towards the rightwards. Okay, simple. Max of root node. Okay, temporary variable, if root is null, return null. Okay, return nothing is there. Otherwise, temporarily, okay, keep the name current is equal to root. Okay, temporary name as root, traverse towards the right side, till where, till the right null. Okay, right node will consider as null. Okay, and the time, okay, up to there you supposed to traverse. Once you get the right node as a null, return that current information. Okay, the node which is having the, okay, the node which having the right node as a null, that is the node which having the maximum value. Okay, this is the basic information. How it traverse. Okay, we are going to see now. Okay, see, listen here. Node, root. Okay, root information is bring from the main function. Okay, which node, which is the root node, that the information is there at the main function, it bring that information. Now this is my root. Okay, how it runs, let's see. I temporarily call the current. Okay, I temporarily call the current node. I call the temporary node current. Okay, if root is equal to null, return root. Okay, check that one. Root is null? No. Root having the information of the node 50. For that reason, it start traversing. How? Current is equal to root. Okay, it rename root is equal to current. Okay, now current and root are both are same. While current of right link is not equal to null. Check that one. Current, this is my current now. Actually, this is my root also. If current of right link is equal to null, check that one. Okay, you not traverse the root directly to the next level. Why? Because you can't come back to the original location if you traverse towards the front. For that reasons, I rename by the current. Okay, rename that node by the current. Okay, current of right link is equal to null. Check the things. Current of right link is null? No. For that reasons, I rename the current is equal to current of right link. See, previously this is my current. Actually, C and current. I rename this node as the current. Okay, now go back. While current of right link is equal to null, check that one. Okay, current is 70 node. This node is the current node. That right link is null. Checking the things. No. Then once again, okay, traverse towards the right, and make this node as the current node. Okay, now once again go back. Current of right link is equal to null. Check the things. Yes, current of right link is null. Okay, you are not having any value over here. And the time this node becomes the node which having the maximum value. Okay, the node which having the maximum value is found like this. Okay, simple. Make root is equal to current, traverse towards the right, and check that one current right link is null or not. If right link is null, okay, say that node itself the maximum node, otherwise traverse towards the right once again, check that node is null or not. Okay. If right link is null, the node which consists that current node, okay, that will be the node having the maximum value, okay, that will be the maximum value. Then finally it returns the current value, okay. Current node is the 80, this node holds the maximum value, okay, nothing to worry. Okay, simple. How to find the maximum value? Keeps on traversing towards the right, okay. If right node is null, says that one, that node is the maximum value. Now how to find the minimum value? Okay, simple, okay, by using common sense, okay, by seeing the properties of the binary search tree, okay. If traverse towards the right, you are going to get the maximum value. If traverse towards the left, you are going to get the minimum value. How it works? Okay, by make some small modification to this, okay, you can rename, okay, you can get that one. See how minimum number, okay, see current, instead of right link, I traverse towards the left, okay. Now see second option is find minimum, okay, by means I use the color chalk, okay, the different, only this is will be the different, I need to traverse towards the left, okay. See my remaining things are same, okay. How it works? Simple. See first I am going to explain the program, okay. See minimum, okay, return type is node, see it calls the function minimum, okay, node of root, okay, root function is bring from the main function. If, okay, I temporarily call the current, see if root is null, return root, okay, nothing is there, okay, no root will be null, otherwise, okay, root will be not null, okay, now root is not null, for that reasons current is equal to root. I temporarily rename the root will be current and start traversing towards the left, okay. If the current of left link is equal to null, keeps on traverse, okay. If current of left link is null, and return that current value, okay. Previously we traversed towards the right, now we traverse towards the left. How it works? Let us see. Now, okay, from the main function, root informations are brought, okay. Now this is my root, see I rename that root by current is equal to root, okay. See check that one, root is equal to null, no, otherwise current is equal to root. Check the current of left link, is equal to null. I am checking the current of left link is equal to null, check that one. Current of left link is equal to null, no. We have the value, the information of the 40, for that reasons, okay, I rename, okay, I traverse towards the left, how? Current is equal to current of left link. Previously this is my current, now I rename current is equal to current of left link, in sense this becomes the current node, okay, current node is 40, okay. Now check back, current of left link is equal to null, check that one, 40's left link is null, no, okay, 40's left link is null, okay, that is the current node actually, no, because it will having the 30 value. On the time I traverse towards the left, and comes, okay, 30 as the current node, Now check that one, okay, 30's left link is null, check that one, okay. See even though if you okay, don't worry, if you are having one more node 35, okay, right link is null, okay, don't worry about those things, okay. If left link is null, check the things, okay. If right link is null, it will be not be the lesser value than the 30, okay. Why it goes towards the right instance? Because of the reason 35 is greater than 30, for that reason it moves towards the right, okay. Check that one, either the 30's left link is null, check yes, on the time return that 30 is the least value in this tree, that is the least value in this tree. Okay, these are the two other operations you can perform. On the trees. Okay, find the maximum, traverse towards the right, find the minimum, traverse towards the left. When you are finding the maximum, when the right link is null, when the right link is null, current right link is null, that will be the maximum value. When traverse towards the left, when the left link is null, okay, when you are traversing towards the left, when the left link is null, that value becomes the minimum value. These are the two functions you can perform on the trees. Okay. Okay. Next. Now, next function is count the number of nodes in the tree. Count the number of nodes in the tree. Okay. Say I want to find how many nodes are there in my tree. I want to find how many nodes are there inside my tree. Okay, simple. You can perform any of these operation. Okay, you can perform any of these operation either in order, pre-order, post-order. Instead of printing function, you are supposed to use the count operator. You start counting there. Okay, instead of printing, you start count that one instance. You are going to get, okay, the count value becomes the number of nodes. That is simple. Okay, I want to count number of nodes in the tree in the sense. Okay, how to count? It goes towards left, it goes towards right. Don't worry about those one. Anyhow, we are having three traversing function, either in order, pre-order, post-order. That is, in order. Okay, you already heard of these things. In order is, okay, left root. Okay, left root, right. Post-order is okay, left, right, root. Okay, pre-order is root, left, right. Okay, when you traversing left, okay, when you having a root, print the information. When you having right, traverse. Okay, this is the informations you followed now. Instead of printing the informations, I use, okay, count operation. I start counting that one. Instead of printing, I start counting. The count information becomes the number of nodes in the tree. How it works? Let's see. Okay, see, count the number of nodes in the tree. Simple. Okay, having the function count node. See, I use the same. See, assume. See how many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8. Okay. See, nodes are 8. Okay. How it counts? How this function counts? Okay, let's see. See, okay, before start tracing, see, I will explain this program. See, initially I made count is equal to 0. Okay, count is equal to 0. Now, void count node, I call the function. See, void count node function. From the main function, I bring the information of the root. Okay, which holds the information where the root starts from in the particular tree. Okay, means root holds the information of the 50. Okay, information of the 50. Now, if root is equal to null. Okay, when the root is null, if no node present in the tree, that root information becomes null, and that time it not going to return anything. It just return controls backs and says that one root is null. Okay, tree is empty. Otherwise, wait, they missed something. Welcome back. Welcome back. The next operations on the trees are count the number of nodes. Count the number of nodes in the tree. Okay. How to count? How to count? See, perform any of the traversing operation, either in order, pre-order, post-order. Okay. In order is left, root, right. Pre-order is left, root, left, right, root, and pre-order is root, left, right. See, what do you mean by okay, in order in the sense, if having the node towards the left, traverse it. Okay, when the root information encounter, print it, and when having the right node, traverse it. Okay, that is the information we are discussing in the previous class, that is a traversing. We are going to perform any of these traversing operation. Okay, when the root information come, previously we print that information. Instead of printing, here we are going to count. Okay, we are going to start counting how many number of nodes are there. Okay, assume this is my tree. This is my tree. There, how many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8 nodes are there. Having the 8 nodes, how to count? We are going to see now. Okay. Now, see, I am going to explain the program first. I am going to explain the program first. See, count node. Count node. See, that is the function I called. It is of the type void. See, node root. Okay, node root. See, it going to brings the information of the root. It brings the information of the root. Okay, the 50 is the root node. 50 is the root node. See how the function work. If root is equal to null, when the root is null, when no information present in the tree, the root is null. Okay, no node present in the tree, on the time root is null, you are going to just return. Okay, you are going to just return the function. Otherwise you are going to traverse towards the left. If traverse towards the left, see here checking that one, right node is null. Okay, see 50 is left node is null, no, otherwise traverse towards the left, traverse towards the left. Okay, now see once again, see once a 40 having the left node, yes, traverse towards the left. Okay, left node 30 having the left node, no, count it as 1. Count it as 1. Okay, simple. See, we are performing in order operation. Instead of printing, we are counting that one. Next, that's it. Okay, now see this node having the right node, yes, traverse towards the right. Checking that one. This one having the left node, no. Next, count it. Count the information as 2. Count the information as 2. Go back. The control comes to here. Left node is over. Okay, next count that information as 3. Okay, next it comes towards the right node. Now it start counted 4. Go back. Okay, left is over. Count the information as 5. Okay, right is there. Yes, traverse towards the right. Okay, next traverse towards the left, comes over here and counts the information as 6. Okay, go back. 7. Go, okay, traverse towards the right and count it as 8. Okay, number of node is 8. Okay, see here what it going to perform, it just perform in order. Okay, in order traversing. Instead of printing, you start counting the things. Okay, see here it going to print this way. If you perform in order traversing, this is the output, that is 30, 35, 40, 45, 50, 65, 70, 80. This is my in order traversing of this tree. Okay, instead of printing, I start counting that one. Okay, instead of printing the 30, I counted as 1. Okay, here it counts like that one. Okay, initially count becomes 0. 1, 2, 3, 4, 5, 6, like that it goes on. Once the traversing is completed, it gives the number of nodes in the tree. It is going to give the number of nodes in the tree. Okay, simple. I am going to repeat once again. Counting the number of nodes is simple by performing any of these traversing method. Instead of printing the node, you start going to count that node. Okay, you count that node. In my example, I performing in order traversing. Okay, where root is null, nothing is there to count. Okay. Otherwise, traverse towards the left. See, when keeps on traversing, we are counting that information. Okay. Lastly, we traverse towards the right. Okay. See, you are performing left, root, right traversing operation as just like you are in order. Here at the printing root informations, we are counting the things. That is it. Okay. This is the way we want to count. See, in the in-order traversing, 50 having the left, go towards, 40 having the left, go towards left, okay, 30 having the left, no, and that time you are going to print. In the in-order traversing, here you are going to count. Okay. Now, traverse towards the right, left, no, print, instead of printing, you count. Okay. Right is there, no, go back, left is over, root supposed to execute it, instead of root it count, goes on. In this way, okay, you are going to count the number of nodes in the tree. In this way, you are going to count the number of nodes in the tree. Okay. Last option of today's discussion is count the number of leaves. Count the number of leaves in the tree. Okay. See, which are the leaf nodes you want to consider. Okay. See, I am going to take this example only. Say which node you are going to consider as an leaf node, you are supposed to understand first. The node which does not having any leaf nodes, the nodes which does not having any children's on the time, those nodes are considered as an leaf node. In my example, you can see here 50, okay, 50 is the root node. Check that one either having any leaf, yes, it cannot become the leaf node. 40 is the node which having 2 children, it cannot becomes the leaf node. 70 can't, why? Because it is having 2 children. Checking that one, 30 does not having left node, but it is having the right node, but for that reason it is not a leaf node. Check that one, 35 is the leaf node, yes, it does not having left node and it is does not having a right node too. For that reason, this is the leaf node. Similarly, 45, yes, it does not having both left or right subtree. 65 also same, it does not having left and right subtree. 80 also same. See, I want to count only the nodes which does not having left node and right node, okay, or means which does not having right subtree and left subtree. I want to count those leaf nodes. Okay, how to count? Have the program over here. Okay, you understand the concept, I think so. Okay, I am going to repeat once again. Okay, which are the leaf nodes we are going to consider? In sense, the nodes which does not having left subtree or right subtree, those nodes are called as leaf nodes. If you having at least one, if you having at least right subtree or left subtree, you can't call it as leaf nodes. Okay, they are intermediate nodes. Okay, how to count? Here I am having the program. See, void count leaf, root information is bring from the main function. How it works? Let us see. Okay, if root is equal to null, returns. When the root is null, no information, no nodes present in the tree, and that time root is null. Otherwise, count leaf. Okay, you are traverse towards the left. You are going to check that one. You are checking that one. Either root left node and root right node is null. Count that one. Otherwise, traverse towards the left. Okay. See, either any of these in order, pre-order, post-order operations you can perform. Same logics over here. Here I am using in order traversing. When you are traversing, okay, we are going to previously print the root information now. Okay, on that, okay, when you are printing the root informations, instead of printing, what they are checking that one, either that node left node and right node informations are null or what we are checking. Okay, if the left link and right link are null, we start counting that one. Otherwise, don't count the things, just traverse. Okay, simple. I want to use the same thing. See, left, okay, root right, I am going to use the same thing. Okay, previously I explained the program by using this only. Okay, left, right, root, left, root, right, left, root, right. Okay, left, root, right. Same informations are at everywhere. Okay, simple. Okay, this is the easiest method. It may takes time, but you are not going to stuck in between. Okay, follow this one. Check that one. Okay, see, count leaf root of left node. Check that one. Either left node is present, yes, control comes to here. Okay, check that one. At left node is present, yes, controls comes to here. Okay, once again, left node is present. Here left node is present, no. Okay, root is present. In the root it is going to check that one. This become the root. The root of left link is equal to null. Yes, this is true, and okay, it is a logical binary logical operator, that is AND. Okay, AND operation in sense both side are true. Only on the time it is true. Otherwise, it is false. Okay, root of right link is null. Check that one. Root of right link is null. No, on the time it execute root also. Okay, next it comes towards the execution of root node. Okay, it having a right node, yes, traverse towards the right. Okay, left is there, no, root, checking that one. It having the left node, no. It having the right node, no. Count become 1. Okay, count becomes 1 now. Previously it is 0. Okay, next it having right, no. It goes back, root is there. It having the right node, yes. For that reasons, it not consider 40 as a leaf node. It not consider, okay, because it having a left node 2, it having a right node 2. For that reason, it not going to consider. It having a right node, yes, executed, controls comes to here. Check that one. Left node is there, no. Okay, node not traverse. Okay, when you are executing the root node, check that one. Okay, 45 having the left node, no. 45 having the right node, no. Okay, on that time, count becomes 2. Count becomes 2. Okay, goes back, right is not there, goes back. Okay, root executed. Either it is having a left node, yes, right node, yes. On the time, it count is not count, okay, incremented there, it traverses towards the right. Okay, coming that one. Left node is there, yes, control comes here. Left node is there, no. Checking that one. When you are executing the root node, check that one. Either that 65 having the left node as null, yes, and right node as null, yes, and count becomes 3. It is get incremented. Okay. Now controls goes back to here. Okay, it traverses the root, left node is there, yes, okay, leave off, and traverse towards the right, comes to here. Okay, 80 is left node is null, yes, right node is null, yes, and the time it count get incremented, and it returns count, return count. Okay, see, when it going to returns the count, okay, the count information holds the number of leaf node in the tree. Okay, these are the discussions of today's. Okay, these are the discussions of today. See, once again, I recap how to count the leaf node. See, which are the leaf node in the sense, the nodes which having left subtree and right subtree as an empty node, as a null node. And the time the tree is, okay, that node is called as leaf node. Okay, how to count? Traverse any of these operation, in order, pre order, post order, not an issue. When you are printing, okay, instead of printing, we are checking that one, either right and left node are null, count that information, otherwise leave off. Okay, that is the leaf node calculation. Okay, see, today's what are the things we discussed. Okay, quick review of today's class discussion. Other tree operations as mentioned in your syllabus. Okay, find the maximum nodes in the tree. When you are finding the maximum nodes in the tree, you are supposed to keep on traverse towards the right only. Okay, when the right node link is null, we are going to consider that node as an maximum node. Okay, that node holds the maximum value. Okay, that is the maximum node. Okay, maximum. Next one is, second one is minimum. How to find minimum? See, in the given tree, keeps on traversing towards the left. when the left link of a particular node is null, even though it's having right, not an issue, even though it's having a right, when keeps on traversing towards the left, when the left node link as a null, okay, that node is considered as an, okay, that node holds the least information or the least value node, okay. That is the two things. Next one is, third one is count the number of nodes in the tree, counts the number of nodes in the tree. Say either you are going to use any of these in-order, pre-order, post-order traversing, instead of printing, you count that information, you start counting, okay. Traverse towards the left, okay, means you suppose root information is supposed to execute it, instead of executing the root informations you are counting, you start count that one, traverse towards the right, okay. I am following here in-order traversing, okay. Now that counts the number of nodes in the tree, number of nodes in the tree. Last one is number of leaf in the tree, okay. What are the leaf node? See, node which does not having left side and right side, okay, both things should not be there, and the time those nodes are considered as an leaf node, okay. See, here also I am using in-order method only, in-order method only. See, I traverse towards the left, okay. When I am executing the root informations, there I checking that one, either that node, left node and the right link as null, okay, is null, and the time I start incrementing the count, I start incrementing the count, okay. Only that count informations here I executed. See, 35, 45, 65 and 80 are the leaf nodes which does not having right childs and left childs, right child and left child, for that is the leaf node, okay. I will start counted those, okay. These are the operations, other operations performed on the trees, okay. This ends up with your fourth module, that is trees, okay. This ends up with the fourth module, trees, okay. See, what are the concept we discussed on the trees, okay. Let's go say quick review, okay. Let's go say quick review, okay. First one is what do you mean by tree, okay. What do you mean by tree? Tree definitions and types of trees, okay. How the trees are represented in the memory, okay. Those concepts we discussed. Next comes under the binary trees, okay. Binary tree, what do you mean by binary tree, okay. Strictly binary tree means what, complete binary tree means what, okay. Those concepts we discussed, okay. Next, continue the discussion regarding, okay, different traversing techniques, that is in-order, pre-order, post-order traversing techniques we discussed, okay, in the next model, okay. Next one is binary, threaded binary tree, okay. Instead since simply storing the null value, we have next reference, okay, that is threaded binary tree we discussed, okay. Next, other operations, that is find the maximum, find the minimum and find the number of nodes and find the number of leaves, okay. These informations we are discussed, okay. See, this ends up with your fourth module. Thank you.